Our entry today is on evaluating and graphing functions. So we talked a little bit about relations and functions in our previous entry. And we've got our inputs, right, our x values, and our outputs, those y values, right, and different representations of relations and functions, being from a table, a list of ordered pairs, a graph, mapping diagram. What we're going to do in this entry is discuss how to use functions, how to write functions giving word statements, or how to graph functions giving a certain set of information. For my first example, we're asked to write the function rule. The output is 5 less than the input. You can think of a function rule, let me flip back here, just like you think of the function machine. The rule is the equation that would go inside the machine. So you put in input, something happens to it, spits out an output. For our example A, or part A, the machine says the output is 5 less than the input. And what I want to say is I want to write a function rule. A function rule is going to be like an equation. Okay. Function rule is like an equation. So how can I make an equation based off that information? So the output, what variable do we use for output? Right, those outputs, that's always the y. So when we talk about the output, it's always going to be our y. Is, whatever we have a word statement that we're trying to make a sentence from, is actually an equal symbol. Right? Y is 5, for example. Right? Is being that equal sign. And then we have 5 less than the input. Well, I know that the input, that's my x. Right? But how do I show that in an equation the output is 5 less than the input? Think about this. If our output is 5 less than the input, and we were to put in 20, well, 5 less than 20 is 15. So out would come 15. So what are you really doing to that 20 that makes it go to 15? The operation you're doing is you're subtracting. So this is really x, or y equals x minus 15. So y equals, and then we've got our x, and I'm going to do this in pink so it might be a little hard to see, this 5 less than, right, that operation is minus 5. Y equals x minus 5. That's my function rule. Right, 5 less than the input. I need to know what the input is first, and then I'm taking 5 away from it. Part B is very similar. Okay. The output is a square of the input. So again, I know that the output is my y. So I'll have a y. Is my equal symbol. Equals. The square of, so in pink that's going to be the square of the input, which is x. So how do I square the input? Well, you simply just write y equals x, and then we're going to square it. The squaring is an exponent. So y equals x squared. So that's example 1. On the left side, okay, you're going to pause the video so that you can do this problem here, this number 1. Write the function rule. The output is 1/4 the input. So pause while you do that, and then you can ask your teacher if you got it correct. Our example 2, what is the value of y equals 2x plus 5 when x equals 3? We kind of went over this already when we did our relations and our functions. We talked about function notation. Okay, so function notation, if I flip back here, right? If you have f of x equals 2x plus 1, and you're asked to find f of 3, you're just putting in 3 for x, and then doing that math out. You're asked to do that here as well. Okay, it's the same process. What is the value of y equals 2x plus 5 when x equals 3? Well, first we have our equation, y equals 2x plus 5. And I know x is 3. I'm evaluating, right? I want the output when x is 3. The 2x, right, plus 5. Two times 3 is 6, and then we add the 5. We would get 11. So y equals 11. And that's it. And now you're going to do the problem number 2 for the on your own on the left side. Find the value of y when x is 5. And you have these equations. This is y equals 4x minus 1. This is y equals 10x. And this is y equals 7 minus 3x. And when you're finished getting those values, you can have your teacher check your answer. Our final example, we're asked to graph the function y equals negative 2x plus 1 using inputs of -1, 0, 1, and 2. So in order to do this, we're going to make an input-output table, right? And our inputs are our x's, and our outputs are those y values. And we're using -1, 0, 1, and 2. We know that y equals negative 2x plus 1. So I have to find the corresponding outputs. I substitute -1 in, and I get -2 times -1 plus 1. -2 times -1 is positive 2. Add 1, we get 3. Right, so the input is -1 and the output is 3. And I do the same for each of my inputs. -2 times 0 plus 1, well, that's going to be 1. -2 times 1 plus 1, that's -2 plus 1, which gives me -1. And -2 times 2 plus 1. -2 times 2 is -4. Add 1, I get -3. And now that I have those coordinate pairs, those x, y pairs, It's just like graphing using a table, using an XY table. We're going to plot these points. -1, my input, went with 3, my output. 0 as an input went with 1 as an output. So 0, 1. So these are my inputs, my X values, outputs, my Y values. 1 went with -1. 1, -1. 2, -3. 2, -3. And now that you have all of those inputs and outputs plotted, you're going to make a line through them with a straight edge. And we're going to use arrows to show that this line never stops. And that's it for example 3. Now that you've got example 3 finished, on the left side you're going to graph the function y equals 3x plus 2. And I want you to use the inputs -1, 0, 1, and 2. Then you'll check with your teacher once you're finished. We're going to do example 4 a little bit differently. So instead of having my document camera and I'm, writing down the notes, what we're going to do is, this is actually just a screenshot of my computer, and we're going to go through this lesson, or not this lesson, but this example that's in the lesson in your book. Okay. So what I want you to do is, if you don't have this handout, I want you to write down this word problem in your book, in the entry for evaluating and graphing functions. So I'll let you pause the video and get that ready. Okay, so we've got this word problem. The number of pounds, P as a variable, of carbon dioxide produced by a car is 20 times the number of gallons, G, of gasoline used by the car. Write and graph a function that describes the relationship between G and P. So we're at a function and a relationship, so we're trying to make an equation that describes that relationship. What we want to do is kind of decipher this word problem and get it down to what the important information is. So I see that I do have a couple variables. I've got P as the pounds of carbon, G as the gallons of gasoline, and I actually have a statement. And that statement is that the pounds of carbon produced by the car is 20 times the number of gasoline. So if I were to put that in words, and yes, I want you to write this down, the number of pounds of carbon dioxide is 20 times the number of gallons of gasoline used. And out of that word sentence, I'm going to break it down even further, okay, to an actual equation. My variable P represented the pounds of carbon dioxide. Is always the equal sign. 20 times means 20, and then I'm multiplying. And then the number of gasoline used, right, the gallons. So my equation is going to be P equals 20G. So that's how I take that word problem and I break it down into an equation. So I've finished that first part. I've written the equation. Now I've got to graph it. Okay. So to graph it, I want to make an input and an output table. And you want to use common sense of what your input values are going to be. So if we look at G as the gallons of gas, we're probably not going to use negative values, because you're not going to have -1 gallon of gas in your car, or -2 gallons of gas, right? That'd be a pretty bad car. So we're going to use positive values in 1, 2, and 3. So if the input is 1, then 20 times 1 means the output is 20. And that makes sense because the output is supposed to be 20 times the input. So 2 is 40, 3 is 60. And once we have that information, we're going to graph it. So what you can do is take one of those small graphs, or you can cut out some grid paper, some graph paper, and make this graph and stick it on the paper. Right? So you'll need 1, 2, 3, 4, 5, 6, 7 horizontally, and then 8 vertically. So a 7 by 8 grid to cut out. And like we talked about, the inputs not having negative values, the outputs aren't going to have negative values. So really your graph isn't going to go into those negative areas. We're only going to use the top right, those positive by positive values.